Keeper 7.3, Trigonometric Integrals. Alright, so we have some strategies. These can get a little crazy, but if you use these strategies, they should help you out. So the first strategy is if you have an odd-powered trig function. It's like sine cubed, or sine to the 5th, or sine to the 7th, or cosine to the 9th. Basically, what you want to do is set aside one of either your sine or your cosine, because you're going to save that to be used for your du. So you'll set aside one of them, and the other ones, whatever's left over, you want to change to some expression where you have your Pythagorean identity. So basically, let's say I had sine to the 5th. I would set aside one of those signs, which would leave me sine to the 4th. And then that sine to the 4th, I would use trig identities to substitute it out, specifically the Pythagorean identity, so that I can change it from sine to cosine or cosine to sine. Now, if you have an even power without any odd, so just all even powers, basically what you want to do is use your what we call power reducing identities. And I don't know if you guys remember these because we don't use them that much in pre-calculus, but your power reducing identities take something that's squared, or to the 4th, or to the 6th, or to the 8th. It takes it and it reduces it down so that you no longer have that power. And when you reduce it down so that you don't have the power, you're left with an expression that you can integrate very easily. So make sure you guys remember or know these power reducing identities. So sine squared u is 1/2 of 1 minus cosine 2u, and cosine squared u is 1/2 times 1 plus cosine 2u. Now, if you have tan or secant, basically you want to try to set aside your secant squared or your secant tan, because we know that we know what would give us the derivative of like a secant squared or a secant tan. So like if we had secant x, I know the derivative of secant x is secant tan, or if I had tan x, the derivative of tan x is secant squared. And so I'm trying to set those aside so that when I do my u sub, I can have the du right there. Sometimes for these problems, you may have to use, again, your Pythagorean identity. So just recall your Pythagorean identities for tan squared and secant squared. Tan squared is secant squared minus 1, and secant squared is 1 plus tan squared. All right, so for our first example, we have the integral of cosine cubed x. Notice that this cubed is an odd power. All right, so we're going to use our first strategy. And our first strategy said to set aside one of those cosines. So I'm going to have the integral of cosine times cosine squared x dx. Now this cosine squared, I basically want to change it. So whatever you set aside, we set aside the one cosine, you want the rest of it to be in terms of sine. All right, so you kind of want to have opposite trig functions. So if I set aside a sine, then I'd want the rest to be cosine and vice versa. All right, so what I'm going to do is I'm going to use Pythagorean identity to change this cosine squared x to be in terms of sine. So I'm going to have the integral of cosine x times 1 minus sine squared x dx. From here, I'm going to let my u be whatever has the power. Okay, so since sine is being squared, I'm going to let u be sine x. And therefore, I know that du is cosine x dx, which is this whole piece, this piece I set aside, plus the dx. And again, that was kind of the purpose of me setting it aside, because I knew when I took the derivative of the other trig function, I would get the piece that I set aside. And so now if I substitute back into my integral, I have the integral of 1 minus u squared du. And then if I integrate that, I'm left with u minus u cubed over 3 plus c. But again, I don't want the u in the problem, so I got to take those u's out, and I got to replace it with my sine x. And so I'm left with sine x minus sine cubed x over 3 plus c. All right, so this next problem, it looks very similar to the last one in the sense that I do have a cube. All right, so again, anytime I have that odd power, my goal is to set aside one of them. And so I'm going to rewrite this as sine times sine squared x times cosine squared x dx. Now remember, whatever we set aside, which in this case is sine, I want everything else in the problem to be in terms of cosine. So I need to take out this sine squared, so that I can put it in terms of cosine so I can find a u and a du easily. So that sine squared, I'm going to change using the Pythagorean identity to be 1 minus cosine squared. Everything else is going to stay the same. And again, using my little trick, whatever has the power is going to be my u. So since cosine has the powers on it, I'm going to let u be cosine x, which means du is negative sine x. And then I can bring that negative to the other side. Now, when I substitute back into my integral, I'm going to be left with negative 1 minus u squared, because again, remember this sine x and this dx went away with the du. And then I'm distributing that u squared. So I have negative integral of u squared minus u to the fourth. And I went ahead and distributed the negative back in to have u to the fourth minus u squared. Now when I integrate that, I'm going to be left with u to the fifth over 5 minus u cubed over 3 plus c. And then plugging my u back in, I have cosine to the fifth x over 5 minus cosine cubed x over 3 plus c. Alright, so in this example we have tan and secant. So the trick here, remember the trick is to either try to get a secant squared by itself or to get a secant tan by itself. I usually tend to do the secant squared method, especially in this problem because the secant squared is already clearly in the problem. So this is kind of what I'm setting aside in this problem, setting aside the secant squared x dx. Which means that since I'm setting that aside, my u is going to have to be tan x. And if u is tan x, then du is secant squared dx, which is this whole highlighted piece, this piece that I highlighted in yellow. And so when I substitute back into the integral, I have the integral of u squared du. And we know that integral is u cubed over 3 plus c. And substitute in my u back out of the problem, I'm going to have tan cubed x plus, or tan cubed x over 3 plus c. Alright, so in this next problem, I see that I have a cubic again, and which is odd. So generally I would try to set aside one of those. However, I don't necessarily need to because I already have a sign set aside. It's already set aside for me. And so that means I'm just going to let u be whatever has the power. So I'm going to let u be cosine 2x. So that means du is negative 2 sine 2x. And I'm bringing that negative 2 over to have negative du over negative 2 equals sine 2x dx. Now plugging that back into my integral and taking that negative 1/2 out, I have negative 1/2 integral of u cubed du. Integrating that, I'm going to have negative 1/2 times u to the fourth over 4 plus c. And then cleaning that up and replacing my u with my original expression, I'm going to have negative 1/8 cosine to the fourth times cosine to the fourth 2x plus c. Alright, so this next problem, we don't have any cubes or anything odd. Everything here is even. So when we have even powers, we have to use our power reducing identity. And so again, if you remember from that first slide of strategies, your power reducing for sine is going to be 1/2 times 1 minus cosine 2x. And then for cosine, it's going to be 1/2 times 1 plus cosine 2x. So I'm going to substitute using those identities. And so again, I have the integral of 1/2 times 1 minus cosine 2x times 1/2 1 plus cosine 2x. Now these two 1/2s, I'm going to take those out of my integral. So I'm going to have 1/4, and then I'm going to go ahead and FOIL this out. So I have 1/4 and then 1 minus cosine squared 2x. Now I'm noticing that I still have a power in my problem. And so I want to, and it's an even power at that. So I want to reduce it again. So I'm going to have 1/4 integral of 1 minus, and then using my power reducing identity for cosine 2x, I have 1/2 plus 1/2 cosine 4x. And from there, I'm going to distribute my negatives. So I have 1/4, and then 1 minus 1/2 is 1/2 minus 1/2 cosine 4x. And now I can integrate this because I know what these integrals are. So I have 1/8. If I pull out the 1/2, I have 1/8 integral 1 minus cosine 4x dx. and then integrating that, I have 1/8 x minus sine 4x over 4 plus c. And if you wanted to, you could bring that 1/8 back into the integral. All right, so in our next example, again, we have something raised to an even power to the 4th. And so I want to use my power reducing identities, but to use my power reducing, it needs to be squared. So I'm going to make this, or I'm going to rewrite this into to be sine squared 2x times sine squared 2x. And then, since I have two squares, just like in the last problem, I'm going to reduce both of those using my power reducing identity. So I have 1/2 minus 1/2 cosine 4x, and then 1/2 minus 1/2 cosine 4x again. Now, taking out the 1/2, I'm going to be left with 1/4, 1 minus cosine 4x times 1 minus cosine 4x. And then distributing all of that, I have 1/4 integral of 1 minus 2 cosine 4x plus cosine squared 4x. Now this cosine squared again, I have a power, an even power, so I have to use my power reducing again. So I'm going to have 1/4 integral of 1 minus 2 cosine 4x plus 1/2 cosine 8x dx. Adding my like terms, I'm left with 1/4, then 1 plus 1/2, which is 3/2, minus 2 cosine 4x plus 1/2 cosine 8x dx. Now integrating that, I have 1/4 times 3/2 x minus 2 cosine, or 2 sine 4x over 4 plus 1/2 sine 8x over 8 plus c. Now, cleaning that up by distributing and getting rid of the extra fractions, I'm left with 3/8 x minus sine 4x over 8 plus sine 8x over 64 plus c. All right, so next we have the integral of secant to the 4x. So basically what I want to do here is I want to use my Pythagorean identity. I'm going to set aside a secant squared. So I'm going to take one of those secant squares and set it aside. And then I'm going to use the other secant squared and I'm going to change it to 1 plus tan squared x using the Pythagorean identity. So now, since I'm setting aside the secant squared x dx, I'm going to let u be whatever's left, without the power. So u is going to be tan x, which means du is my secant squared x dx. So then I have the integral of 1 plus u squared du. If I integrate that, I'm left with u plus u cubed over 3 plus c. And then plugging my u back in, I have tan x plus tan cubed x over 3 plus c.